Hello, everybody, and welcome again back to our final track on the PyCon 2017 last day, Sunday. Thanks so much for being here on a Sunday afternoon. You're going to be excited. I think we're going to have a demo from Benny Bauer, who's going to talk about Python in the serverless area. Please do me a favor, do all of us a favor by turning off your electronics or at least making them quiet. And we will have a 10-minute break following the talk, so there's no need to rush out to try to get to your next talk. We'll give you plenty of time for that. Everybody, please welcome Benny Bauer.
Hi, good afternoon. Am I on? Okay. So glad to see you made it to the third day. I wasn't sure how many will pop here. So in this session, I would like to talk about which frameworks there are to build Python serverless applications. I'll start with, I'll skim through the what is serverless, and we'll get to the demos as fast as I can. My name is Benny Bauer. I came all the way from Israel to talk about serverless and enjoy PyCon. I also heard that Trump is coming for a visit, so I said, it's a good time to go. So here I am. I'm a chief architect at Discover. It's a brand new startup. Our mission is to tell the story of design items and the places they are reside in and the creators behind them. Prior to that, I was a cloud architect at AutoCAD in Autodesk for 7 years. So let's get it going. How many of you heard about serverless before? I guess most of you. How many are using serverless? Okay. So serverless is the latest evolution of cloud development. You can think of it as another abstraction layer on top of compute and platform and infrastructure resources, which makes it easier for us as developers to build applications and ship them. But serverless is also an overused term, and I'll try to make some order in it. So there are three main meanings to serverless. The first one, which I call developer SaaS or software as a service, which is designated managed services that deal with specific things and usually provided by third parties. For example, if you need authentication for your app, you can use Auth0, Twilio for SMS sending, Algolia for search, and you get all of these out of the box, so you don't need to implement the backend of them. Another meaning for serverless is backend as a service, which is things like Firebase and AWS Mobile Hub. They're basically a set of common services that you will need to build your mobile application. For example, you probably need authentication, you need some kind of a basic data store, push notifications. If this is all you need for your mobile application, you'll probably want to use one of the backend as a service services instead of implementing it by yourself and maintaining a backend for this. And but there are still times, maybe most of the times, when you have your own business logic that you need to run on a backend. And this is the third meaning of serverless, which is FaaS, or function as a service. And there, most of the cloud providers, or the largest cloud providers, have a service for this. So AWS has Lambda, Azure has functions, Google Cloud has cloud functions, IBM's Bluemix has OpenWhisk, which is also open source. And the last year when someone mentioned serverless, probably he mentions FaaS, okay? And this will be the focus of my talk here. So what exactly is FaaS? So it's a fully managed compute. You get out of the box a provisioning of an instance, you get the patching of it, you get some basic monitoring and logging, you get scaling out of the box, and which means you have less operations for provisioning instances or maintaining your server. You take your code and just deploy it, package and deploy it, and then the nicest thing about it is that you pay for the actual usage and at a resolution of hundreds of milliseconds, which is, I think, that's the thing that made serverless or function as a service, that made a hype out of function as a service. Basically, it means you have no idle servers, no idle compute. So how it works? As I mentioned, you deploy your code, but then you need to define triggers to what will make this code execute. And triggers are many types of events that you can configure. It could be just an HTTP request, so you define an endpoint that will trigger your function. It could be an event of uploading a file to the storage service of the provider that you're using. It could be a change in a database row or a new row in a database that is provided as a service by that provider, for example, DynamoDB in AWS. And there are many other event types, scheduled tasks, and many, many others. And there are new, almost every month you can hear about a new integration with another service in that cloud, for that cloud provider. And it means that the architecture of the application becomes event-driven, okay? And this is a big change for building cloud applications. If you are used to build applications that poll to see if something happened, so now it's the other way around. And then when the event occurs, it triggers the specific function that you configured, and the code is being executed, and you don't need to worry about auto-scaling and redundancy. You get it out of the box. And the use cases are endless. These are just a few. We can have a talk only about use cases, but the main things that you will hear about them is building a backend, so it could be a web backend, mobile backend, bots, or another popular use case is data processing, using those events of when files is uploaded, when something is changed in the database, when you have a data stream that you want to process. This is very common. So as I said, endless. There are so many use cases, and every other day there's a new post about new use case. But there are also things that you need to be aware of when using function as a service or a serverless architecture. And I'm not going to go through them because, again, it's another topic for a full talk. But you need to understand that serverless is not a silver bullet. You need to understand if it works for your use cases, and you need to know the limitations and how to overcome them. Okay, so we got to Python. Okay, we're in PyCon, so let's talk about Python and function as a service. So out of the cloud providers, AWS, IBM, OpenWhisk, and Microsoft Azure support Python, both Python 2.7 and 3.6. Azure is still experimental, but you can already try it. But if you already had a chance to try and deploy functions and configure everything, you know that it's not easy. And that there's a lot of things that you need to tweak and configure and define and package and deploy. And we as developers, we're lazy, and we always invent things to make our life better. So there are frameworks for doing this stuff. And these are some, I think, most of the frameworks that support Python runtimes. We'll go through some of them. I'll start with serverless. So if the term serverless wasn't confusing enough, It has another meaning, which is a framework called serverless. By the way, all of these frameworks are open sourced, and you can go through the code, you can contribute, you can add stuff. So the serverless framework, I think it's the most mature, and when I'm saying most mature, it's 1.5 years old, maybe. Serverless is such a new thing, so 1.5 years in the serverless terms is a lot. That's what makes it most mature. It also supports the different cloud providers and various runtimes. So I want to show a demo of building some simple Python application with the serverless framework. Serverless framework itself is built in Node.js. You install it by using npm install serverless, and once you installed it, you can create a project. You can create a new project out of the template using the CLI. So this is something that's common to all the frameworks. They usually, the way they work, you configure, you use a CLI and you configure a configuration file with the rest of your code, and the framework does everything for you. So I want to create a Python project for AWS to deploy to AWS. So they have templates. So -t for template. I want to have Python. This one is Python 2.7. And let's see what I got. So, sorry, my bad. I wanted to create a new folder. Okay. So what I got is I got two files created for me. I got the serverless YAML, which is the configuration file, and I got a template of the function itself that I'm going to deploy. So let's start with the serverless YAML from the configuration file. You can see that you can configure the provider. As I said, it's not only for AWS, but this project is a template of AWS, and the runtime is Python 2.7. And I want to configure that the region will be Oregon, so it's US West 2. There are many things, examples for many things that you can do, that you can configure, but I'm going to skip them. And I'm getting to the function itself. So this is the definition of the configuration of the function. So I have, out of the template, they created me a hello function in the handler py file. And now I want to bind an event to trigger this function. So they have some samples here. I'm just comment out the things that I want. So I want to create a simple HTTP API that when someone calls hello and provides a name argument, and this call is a HTTP GET call, it will trigger my function. And let's go to my function. So this function was created out of the template. Let me just move some redundant things from here. And what you can see in this function that I get two arguments. The first argument is event. Event is the input of the input of the event that triggered this function, and context is the runtime information about the specific Lambda. So I have a body that I want to return, and I define the response, the status code of the response, and the body that I have up above here. And I just want to say hi, and I want to get the name out of the argument that was sent to me. So this argument is in the path parameters. And as we configured in the YAML file, its name is name. And that's about it. Now I'm ready to deploy. All I need to do is SLS deploy and hope for the best. So what happens now? The framework packages all my code and starting to create the resources that I need on AWS to be able to deploy the function, to bind it to an API gateway, which is the HTTP gateway that maps an endpoint to my function. It also configures a bucket to upload the code to. It will configure the different security roles that I need for the API gateway to call the Lambda function, and also logs. Everything that you see here, if I wasn't been using the framework, I needed to do it by myself, either by going to the AWS console or using the AWS CLI. But here I did it with just by configuring a configuration file and using the CLI to deploy it. So usually it takes a few minutes. It also depends on the amount of resources that you configured for this project. Hopefully it will be done. Maybe in the meantime, I can show you what other things you can define in the YAML file. So I could have defined that the event that will trigger the function would be an S3 event, which is the file upload storage event, or a scheduled task, or many other different things that can trigger my function. I can also pass environment variables through the configuration file. I can define other resources to be created on AWS if I need. Let's say I want to create another bucket for my project or a DynamoDB table, so I can do everything through here. Okay, so it's done. I have this endpoint. Let's curl it and say hello PyCon. And I got it. I got the response back. Didn't need to spin a server. Didn't need to do anything to go to a console. Everything is here from the CLI. Okay, but that's the simple case. Now I want to add some dependencies to my Python project. So I'll create a virtual environment. Let me just update my pip so it will not bother us. Okay, and let's say I want to add arrow because I want to display the time. I know I can do it with daytime, but I love arrow, so let's do it with, let's add arrow. And I also want to create the requirements file. Okay, so now, theoretically, I can go to my function, do import arrow, add some time variable, let's write a time. And let's write both the UTC and the Portland time, just to justify my arrow. So it's to US Pacific. Okay, but how will serverless will know to package all my requirements and also bind them in the code? So for this, the nice thing that you can do with serverless is that it's pluggable. So anyone can write a plugin that hooks into events in the framework and implement stuff. So there is a nice plugin called Serverless Python Requirements. I'll install it as I said, it's a node. So and I also need to edit to my YAML file to configure it to work with it. So let's go to the YAML. I'll add a plugins section and put it here. And again, I'm deploying. And now you'll see that it takes the Python packages from the virtual environment, and it will create a .requirements folder with my packages and package everything together, deploy to AWS. This time, it only goes for the changes that need to be done. So this deployment should be quicker, and let's curl again, and I got all the data, the time, and the message. So this was an example of using serverless framework. Let's see another example that is unique for Python, and this is a framework called Zappa. It was developed by Rich Jones. And the idea of Zappa is that if you already have a WSGI server, for example, you have Flask or Django, and you want to take it as a whole and deploy it to Lambda because you don't want to manage your servers, so you can use Zappa for this. And it's super simple. The way it works, it packages your, let's say, Django or Flask application. It uploads it to a Lambda function, it creates a proxy through an API gateway, and so you don't need to define every endpoint that you have on your API, and it handles it for you, and it's super easy because let's say I have here a basic Flask application with 2 endpoints. It converts currency. So what I need to do is just create a Zappa init. I already pip installed Zappa, okay, and when you do Zappa init, it will just ask you for different configurations. I'm going with the default here. And it created a configuration file, which is called Zappa settings. So again, here I want to change the AWS region, and there are many other stuff that I can configure here, but we will not get into it. But it has a lot of functionality that you can do here. And again, Zepa Deploy, it takes about a minute, and it does, again, it takes the the virtual environment that you're in. It takes all the dependencies from this environment, packages everything with your code, and creates the needed resources on AWS, the API gateway, the S3 bucket, uploads everything, creates a Lambda, and then you got it. Okay, so let's take this, and so we said that we have 2 endpoints. So this is the first one, the hello, and we have another that convert, let's say, from dollars to euros, and convert 20, to euros and convert $20, and you got the response. Again, you didn't need to spin anything, doing everything from CLI with a configuration. There are pretty unique features in Zappa. For example, you can do a global deployment. So instead of deploying a Lambda to one region, you can deploy to all the regions in AWS. There's also a functionality for keeping it warm. It's something, one of the limitations of Lambda, where the way it's implemented is it runs on container, and when you're not calling this container for 5 minutes, it will become cold. So next time when you call it, it will might need 2 seconds to get warmer. So if latency is something important, you get here kind of a trick of keeping it warm. It also supports using the Lambda packages and many Linux wheels packages, which are precompiled packages for Python precompiled packages that are suitable for the AWS Lambda instance, the Linux version that they use. Another framework is Chalice. It's by AWS. It looks very similar to Flask. Unlike Zappa, it automatically creates a separate endpoint for every route that you will define in your code. But again, it's very simple to use. You create a new project from the CLI, and you define everything in your code, and then you deploy. Last thing that I want to show you is it's not a framework, but a library called Pyren. It was developed by Eric Jonas. He's a postdoc in Berkeley. And it's simply a library that enables you to take a function from your code and at runtime distribute it to endless amount of Lambda functions. So there's a nice example by Sean Smith that he used it for web scraping. He created that's the whole code. So he has a scrape function that takes a URL, and using Pyren, you create the Pyren executor, and then you call to the map function of Pyren, and you pass the function that you want to be executed distributedly, and you pass an array of inputs. So in this example, it's an array of URLs that he wanted to scrape, and that's it. And what happens behind the scenes is that during execution, Pyren will create those lambdas, will deploy them, deploy them, and configure all the roles that you need, and basically it's just one line of code. And I think this is an amazing example of what you can simply do with serverless. Okay, so we got to the end. A few takeaways that you might take is that serverless is pretty fast to develop. It's cost effective for most use cases. We didn't talk enough about limitation, but you should be aware of when to use it and when not. And you can do it easily with Python using the frameworks. And for those of you who contribute to frameworks or like to build stuff in open source, I think there's plenty of opportunities in the serverless domain, because there are many problems and challenges to be solved there, and there are many tools that can be built to solve these issues, and Python is one of the best tools to do that. That's it. Thank you. If you have any questions.
So we got about 1 minute. Happy to take one question here, and then Benny's offered to also meet people out in the hallway too to continue questions. Yeah.
Sure.
Okay, great. Go ahead.
Hi. I really enjoyed your talk. I was wondering if you have any preference or comments about the config files being like YAML or JSON format, like on the ease of maintenance.
For me, YAML is easier.
Easier.
Less code in YAML.
Thanks.
Okay.
One more. How easy is it to switch between some of these frameworks? Because I know they're all kind of young, and so if we pick one and then in 3 or 4 years it turns out we picked the wrong one, are the configurations kind of similar where you can? Obviously, it's not trivial, but like, what's the effort involved? Have you converted projects between these different frameworks?
Yeah, so 3 or 4 years in terms of serverless is eternity, so it's hard to say what will be in 3 or 4 years. But I think it's every framework has its own configuration and configuration style, so it's not trivial. The code itself is the same programming model, so it's easy, but take the configuration and replace it. It's not trivial, but it's one file, so it shouldn't be too hard. Thank you very much.
Let's give Benny a big hand. Thank you very much. And we'll take a 10-minute break.